Hi there, myself Madhav Jha. I welcome you to CodeChef and let's have a look at this question.
The problem is plus minus split. The problem difficulty is easy and there are no prerequisites. Let's have a read at the problem. You are given an array A of length n. The array can be modified by performing the following operation on it. We'll choose the index I, then we'll go over each index and then we will check if the index j is less than the index I, the one that we have chosen, then we'll add the element ai to aj. If that is not the case and j is actually greater than or equal to I, then we will subtract ai from aj. Now, note that every element of A must be modified. You cannot leave elements unchanged. We would like to make all the elements in A equal by performing the operation as many times as it requires. Now we need to know whether it is possible to achieve this goal, that is of making all the elements equal. So for the input format, we have t test cases, and for each test case we have two lines. The first line contains the integer n, and the second line contains n spaced integers that are a1, a2 till an. As for the output, we simply have to output yes or no, depending on whether it is possible to make all the elements as equal or not. As for the constraints, number of test cases will go from 1 to 1000, length of the array will go from 1 to 100, and value of the elements will go from minus 1000 to 1000. Let's see some sample inputs. So for the first sample input, our array has two elements, 1 and negative 1. Let's say we choose to perform this operation on the 0th index. Now if we do so, since the index is same, right, we will perform the second step. That is, we will subtract, sorry, since we perform the second operation, that is subtract ai from aj, right? So we'll subtract 1 from 1, that will make it 0, but we'll then also subtract 1 from negative 1, that will make it negative 2. And with this, all the elements are not same, so this will not suffice. Let's say we choose the element first. Now if we do this, since now in this case the uh, index 0 will be less than the index 1, we perform the first operation. That is, we first add the element that we have chosen, that is negative 1 in this case, to the first element. So in this case, this becomes 0, and again negative 1 minus v2 negative 1, this also becomes 0. So both the elements of our array are 0, therefore it is possible to convert this. Similarly, the last has all the elements as equal, so there is no need to perform any operation, and by default the answer is yes. Whereas in the second sample input, we will find out that it is not possible to make it all elements equal. Therefore, the answer is no here. Let's see how we can approach the solution. The very first base case is that all the elements are already equal, like the third sample input that we have here. If that is the case, the answer is by default yes. Now, if that is not the case, what can we do? So if you have seen the examples that we have went through, you know that when we perform the operation, let's say if we have chosen I, once we start performing the operation, it is for sure that element a of I will become 0 because I is equal to I. Therefore, we perform the second subtraction operation. Now once this is 0, let's say we move on to some other operation. Whether that operation is before I or after I, it does not matter, because now this element ai will be changed whether something is added to it or something is subtracted to it. So it will not be possible to have it equal. If we want to have all the elements equal, we must make it to 0, otherwise it's just not possible. Since the constraints of the problems are small, that is n in only 100, what we can do is we can simply perform this operation on each index. So let's say in one operation, if we can't make it 0, then we cannot make it 0 in any more operations, because as we have seen here, once we make it 0, if we try to perform any other operation, this 0 will be altered. So what we'll do is we'll go over each index I, going from 0 to n, and within this will be the chosen index I. We will again go through all the indices, that in this case will be our j, and check if after performing this the complete array is 0 or not. If it is 0, then our answer would be yes, but if that is not the case, our answer would be no. And with this, we'll get our solution. Let's see how we can implement the solution in C++. So for each test case, we call the function solve. In solve, we take the input of n and then the input of our array. Now once we have this, we go over each of the indices going from 0 to n. Now this is the chosen I index as we have seen in the description and approach. Now again we go over all the indices that we have named as j0 to n. Now if j is less than I, we add our element, that is ai. If that is not the case, we subtract our ai element. Now we need to make sure that this operation makes the element 0. If it is not 0, then we know that applying this complete operation is useless because we will not be able to make all the elements as same. Therefore, we have set a result variable. We initialize it as 1 in each operation that we perform. But if we are not able to make element 0, we make it 0 and then we break off. But on the other hand, if we find out the result is 1, that this operation is successful, we again break out because now we know that it is possible to do so. Now depending on the result flag, if it's 1, we print yes, otherwise we print no. And as you can see, I have AC in my C++ implementation. Let's see how we can implement this in Python. Again, for each test case, we call the function solve, take the input of n and our array. Then we go over each index and perform the operation. We keep a result flag to check whether it was possible to completely transform the array such that all the elements are same. If it is, we set the flag to 1, otherwise we reset it to 0. At the end, based on the value of the result flag, if it is set, the answer is yes, otherwise it is no. And as you can see, I have AC in my Python implementation too. So I hope you understood the problem, the approach, and how we implement the solution in both C++ and Python. Have a very good day, and I'll see you in the next video.